Hey everyone, I'm Nicholas DiCola, the VP of Customers and Security Jedi here at Zero Networks. Today we're going to talk about containing ransomware, and we're going to demo the Zero Networks platform for automated microsegmentation. Before we get into that, let's just quickly talk about some of the issues and why microsegmentation matters so much today. So even according to Gartner, an industry analyst, there's various reasons why microsegmentation matters so much now. There's unknown vulnerabilities, there's compliance requirements, there's network complexities, but ultimately you need to lock the network down to stop lateral movement and contain attackers if they get in the environment, right? And that all stems from networks being too open and accounts being too permissive. So once an attacker gets in, and that could be through a spearfish, through a drive-by website, it doesn't really matter. They're able to laterally move and spread across the environment and ultimately get to the crown jewels in a very quick time. I think there was even a stat from the CrowdStrike report that they laterally moved within 51 seconds. So the Zero Networks platform is one platform to really help solve some of the biggest challenges in zero trust. The first being network microsegmentation. And this is for clients, servers, cloud IaaS and PaaS, OT, IoT. It doesn't matter. It's about segmenting the network down to the smallest component, each asset, and putting a firewall bubble around each one. On top of that, you're still going to need to leave some things open. So you want to limit identity least privilege or segment identities such as service accounts and admin accounts across the environment so you can limit where they can log in and not expose them in a way an attacker can get them. And ultimately extending outwards from inside the network is zero trust network access for remote employees or external access. But we're going to focus in on the network and identity segmentation in Zero Networks. So let's jump into a demo so you can see how this is super easy and automated in the environment. So if we flip over here to the Zero Networks portal, when you log in, you can see segmentation status across your environment. How many assets are segmented? How many are in learning? How many need to be segmented, et cetera, et cetera. So just some quick stats across the environment. But most importantly, you can dive in and look at entities, all of your assets, all of your Kubernetes clusters, all of your accounts, whether they're service accounts or human privileged accounts. And more importantly, there's lots of grouping technologies in Zero Networks, because when you build rules for identity and network segmentation, you don't want to say server A and server B can talk to server C. You want to say app A, which contains server A and server B, can talk to app B, which contains server C. So we have lots of grouping technologies that we bring in from your environment, like Active Directory groups. More importantly, during learning, and we'll talk about learning in a second, we have a function we call the tagger that tags commercial off-the-shelf software and groups those for you. So those can be used in rules. And we can even bring in your ServiceNow CMDB data for your business application context to be used by the automation engine. Now, the first part of network or identity segmentation is monitoring. And in monitoring, we connect agentlessly to each asset in the environment through various native methods to collect the network connection events or identity event metadata in and out of each machine. So here we can see things like the user, the process, the source, whether it was blocked or allowed if the machine was segmented. Here I can see this machine is not segmented, so there's no Zero Networks control over that connectivity. And I can see the destination. Now, most of these are outbound to the internet, so we can also see the domain name. And if I scroll down here, we can also see if we're connecting to another machine in the environment that we're monitoring, we also get that destination process. And you can do some really cool things here, like just from the monitoring and visibility, if I want to look for all RDP traffic, so this is actually finding the RDP asset. So let's do it by port. If we look for RDP traffic on port 3389, I can quickly see what are my top processes using for RDP across the environment. And most people are using remote desktop, MSTSE. Some people use RDC-man, some are using PowerShell. And then there's a Defender service that's also using this as well. And I can also quickly see that most of these are allowed. Some of these are blocked with MFA. We'll talk about why MFA is important in a second. But these visibility that you get from monitoring the assets, which is the first phase of segmentation, is very easy. You can search and filter on all of this data from both a network and identity perspective. Next, once your assets are monitored, you can then add them to learning. So I can literally take a laptop here. Let me just find a machine in our environment. So we'll pick on his laptop. and I can say learn and segment, and I can add it to learning, learn for 30 days, and automatically segment at the end of those 30 days, or I can segment immediately if I know this machine is ready to be segmented. So once a machine is in learning, you can then see when it will learn until, for how long it will learn. And it will let you know here that this one will be segmented on September 6th, for example. And you can also click on that machine or any asset, as well as any group of asset, and get a sliced view of all the data across the environment. So I can see rules that will apply to this server. I can see activities that are specific to this server. I can do a network analysis, which summarizes all the activities to this server. And I can see there's 37 different assets, 14 users, 16 different processes talking to RPC, which is LSAS, about 6,000 times in the last week. And you can actually visualize this as well. So I can see all of the network analysis data in a visual map of what is connecting to the asset, broken down by things like client and server. And it will load here in a second. We do this in real time so that you get the latest data and the latest visual when running this. But I can quickly see there's inbound and outbound traffic because this line has 2 arrows. I can see this domain controller only talks outbound to the internet, which is good. And you can click on any of these and get a summary of the top destination ports incoming and source processes incoming as well as outgoing. And if I see this key, that means there's some privileged access going across that connection, and I can click on that and see a summary. I can also click on these boxes and see all of the specific assets and click on any one of them and get a summary of the data for that specific asset in the environment. And then right before segmentation, again, we automatically segment to save you time because we automate building all of the rules for you during learning. You don't have to build any of your network or identity segmentation rules. You can run a simulate segmentation. So here I can take that network analysis data and compare it to my rule set that will apply when this machine is segmented. And I can see all of the traffic that's allowed, all of the sources that would potentially be blocked. I don't have any in this view, and anything that might be MFA'd. Now, once we segment an asset, one of the things we don't do during learning is we never learn interactive privileged traffic, because this is how attackers laterally move in an environment. So if you want to contain ransomware, you want to lock down all of that privileged network and identity access. And so we build very simple MFA policies that says, hey, once an asset is segmented, if any user using any process or any asset tries to connect to a segmented machine on 3389, which is RDP, or 5985, which is Windows Remote Management, the user must pass an MFA method. And if they do, they will get a rule for 12 hours. So we have a patented just-in-time capability to build that rule on the fly after the user MFAs. Now, I can also lock this down. Maybe I don't want all users in my environment to be able to RDP, and I only want to lock it to certain administrators. So if a user is not an administrator and they try to RDP, they never get the MFA prompt. They're never able to connect and open that just-in-time rule. But in Zero Networks, we can prompt that user if they are an administrator. So just to give you an idea of what this looks like and why this is super important for blocking lateral movement, if I want to go connect to, say, our RDP server, I'm going to get prompted here in a second for an MFA. And I'm just checking my phone because I'm getting a prompt on my phone. You can also see we opened a browser. You can hear I got an email. Hey, Nicholas is trying to connect to that RDP server from his laptop using 𝗦𝗲𝗀𝗀𝗶𝐺 over 3389. And here I'm going to go ahead and sign in with my Microsoft account, which would take me through the Microsoft sign-in. Now I'm already signed in because my email is logged in, so I didn't have to MFA. We can override that sign-in and enforce the user to MFA if you want to. And now that I've approved that connection, if we just go back to the console to look for 1 second, we created and deployed a just-in-time rule that says Nicholas's machine can talk to that RDP server on 3389, and it's time-bound. It will get deleted after a period of time. So now, just to go back to the connection here, it timed out because I was walking you through this, but if I connect, I now get prompted for username and password, which popped up on the other screen over here. So if I just grab this and move it up, you can see I'm getting prompted. That port is now open to me. And just to show you what it looks like from a network analysis perspective, if I go back over here and I search 3389 and I search my machine, now we can see that when I went to connect to that RDP server, it was initially blocked and triggered an MFA, which checked those MFA policies. And then once I pass that MFA, now I'm allowed to access that machine, right? So that rule that came up, and you can click on this and see the actual rule that allowed the traffic. And this was from yesterday when I did this as well. Now you can see that that traffic's allowed. So the important point here is we're closing down the network on all of these assets and identity when we segment them to only the few things that are needed for an asset, and anything that's privileged now requires a just-in-time MFA access. This is how you contain ransomware in the environment. So let's just go back here to our presentation to wrap up. So if you think about this, if you've micro-segmented your network from a network and identity perspective, now when an attacker gets in and they get to that very first machine, they're unable to laterally move. And if they can't laterally move, then they're not able to spread, and thus you've contained ransomware in your environment. So we make it very easy to do that. So just remember a few things. We're agentless, we're automated, and we have just-in-time MFA so that you can segment your network with and identities and make it very easy to actually achieve that in a very short time period through an automated learning process. Thank you for taking the time, and I appreciate you watching the video. Again, I'm Nicholas DiCola with Zero Networks. Take care.